Akshata, Priya.
Good afternoon, sir.
How are you, all of you? Everything is fine? Hope I am audible, right? Hello.
Yes, sir.
Yes, sir.
Yeah, please try to interact. Regular classes, right? Whenever you have classes or labs, please try to interact. Some strength and interaction. Okay. Anything you want to discuss? In the other 5 minutes, we can discuss. By the time some of the students will come, right? Any queries and questions you have? Are you able to see that properly? The text in the slide? I can see some pixels are not displayed. You're able to see clearly?
Yes, sir.
Yeah. Okay. So this is the last topic what we have in your fourth module. The 2 minutes will begin. So today we'll see how the files get processed while opening a file or while closing a file and during the file operation what is happening. Okay, so this part we'll try to discuss today. It's very interesting to know. Let us say we have one file with us. The file name is A, and if you want to open this file, you want to try to open this file, what all things it will happen. So that we're trying to see. After opening, what all it's going to do, it's here after opening. And after closing, what all things it will happen is what we have here. Okay. So this file processing is a part of your CO4, 4004, which is from module, 4, and we can go up to knowledge level 4. K4 we can reach up to. So that much knowledge we can learn from this company. Okay. So let us begin. Okay. So let us discuss now. For first 10 minutes, we'll have a discussion on how to open the file, and after that, we'll see how the things will happen during the file access or file operation. And after that, we'll see when it is closed. Okay, open, file happening, and close. So these things we are going to see. So let us see one by one. The file system actions at open. Whenever you are trying to open a file, what are the things happening here? So we have to set up FCB and OFT. What is FCB? Anyone of you remember? F stands for file, B stands for block. What is C? What does C stands for? FCB. Remember the, let us see one by one. Next, what are the things happening when during the file operation? Like how the disk allocation is being done, how the disk space is being used. This is what we have seen in the previous class, right? So this topic we have seen for the disk space. Okay, what is the what we have our disk allocation? Disk space allocation. Disk space. And next is file system actions at close. At close means what? Updates directories if necessary. Regarding the close option, what all directories we need to update if necessary. If we need to update them, what is that to be done? This is what we have to do. Next, file system actions at open. So this is what we are trying to see, right? For open, during this open part, file system action. So what we need to do? First step, what we need to do? Perform path name. Yeah, meanwhile, let us try connect. Yeah. So, right. So let us see here what is happening. Okay. Perform path name resolution. So what is the path name? Path name means what? So if you see a file name, any file name, we have a C column, double slash. We use file one. Inside this file, we have folder one. So inside this, you have, let us say, mini project, right? And we have, let us say, PPT in that. Let us say, uh, .ppt something. Okay, so this is what the file we have. Now, what we need, perform path name resolution. What does it mean, path name resolution? For each component in the path name, locate the correct directory of file. One second. Yeah, let us review. Yeah. Perform path name resolution. What is this path name resolution? Let us see that. For each component in the path name, locate the correct directory of file. So whenever you have each path, so this is the path, let us say. Okay. For this PPT corresponding file, the path, the folder is mini project. And for this mini project, the folder is, so like when you try to open, right? When you try to open it, let us say if you expand this one, let us say this is file. And this is your C directory. And if you expand this, you will get a lot of folders. Out of those, one folder is folder 1. Okay, again, if you try to expand this one, if you expand this one, so what do you get in this? You get again project. So like that. So each one should have its own path name and locate the correct directory for the file. Locate the correct directory or file. So this is what we need to do. Handle path names passing through mount points. Handling path names passing through mount points. So what we need to do? So wherever you are trying to mount the corresponding file, we need to handle the path. Okay, you can create the folder anywhere, right? You can create the folder anywhere. So when you are trying to create the folder anywhere, so that path has to get triggered. Okay, that's what is your handle path. Let us say you go to your computer, my computer you go, and you go to C drive or D drive or E drive, anywhere you go, and again you create n number of folders inside that, and you try to create that directory or you create that file, path should get created by itself defaultly. Okay. So what is the example for that? A file should be allocated disk space in its own file system. It means so you have n number of folders. Let's say one folder we have here, we expand this, one more folder we have, expand this, we have one more folder. Whatever folders it is having, it has to be the data of the file what we have, the data what we have in this has to be in that corresponding folder directory. This information was there inside this. This complete information was available for this, and this information was available for the next one. So like that. Okay, each one of them has to maintain its own information. That is the first one. And we need to also build FCB. Okay, file control block, let us say, FCB we need to build for each of the files. Whatever files you are trying to create, that corresponding FCB will be created. Why FCB will be created? By using this FCB only, you can access the continuity of the one file to other file. Let us say one page to other page, we can get the access continuously. That is the first point. What about second point here? Retain sufficient information to perform a close operation on the file. We need to retain sufficient information to perform a close operation on the file. We need to do a close operation on the file. What does it mean? We need to have all the information relevant such that that can be, it can have, what to say, the complete information whenever you are opening or whenever you are closing. The path should be known for the file. Okay. So close may have to update the file entry in the parent directory. So whatever information we are trying to do, we need to update that corresponding information in the file access. Right? So we have this is the path what we have. Here we have one folder, and inside this we have n number of folders. Let us say one more folder here. Now this will be acting like a parent folder, and this will act like child folder. Okay. If you do any changes in the child folder, we need to get updated in the parent folder also, directly parent directory also get updated. So these things you should know when to open. Okay. See this one here. This is like an directory root. This is one directory. If you expand this directory, you get other directory. This one we got. Okay. Inside this directory, we have the information about this FMT file. So we have told, right, FMT. Okay, this FMT file, what we that information is called FMT means what? File map table. That information was available here in this page. The information was available. So what this is going to do? Each file, whether you want to open the file or you want to close the file, whatever it is, from one to one, how to connect it, how to link it, is what we have the idea here. Okay. So we have FCB pointer. FCB pointer is pointing out for the information here, and this pointing out for the file name. This is the information what we have, which means information means what? First, which one? Let us say these are the blocks of memory. Okay, first block of memory, second block of memory, third block of memory, fourth and fifth blocks of memory. Now I can store. I want to store 1, 4, 7, 9. This number I want to store. I can store 1 here. I can store 4 here. I can store 7 here. I can store 9 here. Randomly I am storing it. The first one it will store here. Let us say it has to go to this line 4. After 4 it has to go to 7. After 7 it has to come back to 9. Okay, like this, wherever the block is free, depending on the freeness of the block, we are going to use the space. Okay, so that information, which block is used, which block is not used, this was available here, which means the corresponding directory, it is free, or let us say it is free or it is allocated. It is free or it is allocated. Based on these two, we are able to get the information from that. Okay, and the corresponding file, whatever file we have, sorry, whatever file we have, that information this one is here only. Whatever file you have, that information will be updated in this. Okay, so based on these things only we can able to open a file. If you want to open a file, so these many inputs or information are required. So what is that it required first? It requires a directory, and after the directory it needs the file, and after the file, when you try to open the file, it will invoke the file called FMT file, file map table file it will invoke. Based on that file map table, whatever information it is pointing out to, it will do the actions accordingly. Whatever the it is pointing out, let us say here it is pointing out. So based on this, where it is working, it is with the information. So it will point out, it will point, it will take this information. Like that, whichever levels you have the information to point out, that it will be taken care. Okay, so this is how we can able to open one corresponding file. Okay. Whenever you want to open a file, this is the process what will happen inside the operating system. So 3 things you need to know here newly. One thing is FMT file, first thing. Second thing is FCB block for information, FCB block for the data. So this much is used for the data file. Whatever file you have, that data file it will be having inside. Okay. Next. So file system action during a file operation. File system action during a file operation. Each file operation is translated into SLP, which means whenever you are trying to open a file, we have seen, and now after opening the file, what all things we need to maintain. Okay, 3 things. What is the 3 things here? What are the 3 things here? What we have? 3 things what we have. One is during opening phase and during that phase and closing phase. During opening, during the operation, okay, and during closing. So this is what we have seen open. Now we are trying to see this during operation and further with the closing. So during this operation, during a file operation, what will happen here? Each file operation is transferred into a call. Whenever you are trying to open a file, let us say you have one folder. Let us say folder name is operating system OS. You open this folder, inside that you have n number of folders. Module 4. So this is the file module 4.docx. So this is the file what you have. Now if you are trying to open this file, what will happen? It will initiate a call. This will initiate a call. Okay. What this call is initiated means what information we have? We have the information like internal ID, record ID, internal ID, record ID, and IO address. Okay. So what is this one by one? Let us see. Internal ID. So internal ID is the, see they are telling internal ID is the internal ID, which means for internal reference it is created. It can be, let us say, XYZ, right? Or it can be 1, 2, 3. Whatever reference. See, this file name I gave module 4. I can also give XYZ. I can also give 1, 2, 3. Let us say this internal ID I gave module 4. This will become now module 4. Let us, for example, to understand, module 4 is the internal ID. Okay. Or if you feel like no, it has to be made sure that internal ID, it can be like this to make you understand much more clearly what we can do. C drive we have. C drive in this we have taken 6M. Okay, in 6M we have operating system. Let us say in operating system we have module 4. Okay. Now some internal random ID it will create here, and this file name here it will go here, returned by the open source. So this will go into the file name. So it will create some internal ID here, not the file name. So random file name based on the protocol what is going to use, random file name will create, and along with that we create some record ID, record number 1, 2, 3, 4, and keep going. Depending on number of files you open, let us say you open 100 files, so record number can be 100. It starts from 100. If you open 1000 files, record number can be 1000. So like that it keeps going. Okay. And what is the record ID? Is the absence of sequential access files operation. So that's what. If you create 100 files, so record numbers can be 1 to 100. If you create 50 files, it can be from 1 to 50. So that's what the record ID. How many you create? Even you delete it, one record is created. Okay, so like that it will have the record ID. Okay. So it's very simple to make you understand what is this during opening time, what will happen is, let us say your attendance only, you take example, is your attendance. You will have serial number, you have USN number, and you have your name. Okay, you see this one? So this internal ID is like your roll number, 1, 2, 3, 4, like that. And record ID is your USN number, 1, B, so on. Is your record ID. Okay, and what we have, the name can be your file name. What we have, let us say, start with A, B, C, something, B, A. So that is your file name. So like this, how we have, whenever you want to access it, you should know the serial number, you should know the USN number, you should know the name. Then we can access this corresponding. All the information corresponding to that should be available. Okay, so that's similar to this technique what we have. They are also following that kind of approach in opening the file, and after opening, how to operate on it. That's what they are trying to discuss. Okay. So we will get the information about the disk address from record ID. Whatever record ID we have here, right? From this record ID, we can able to get the disk block address. Okay. Now during the file system action at close, so during close operation, have the information of file. The file information is updated here. We have some file information here. Now this file information is given to a block. What is this block? This is called as your file map table, FMT block. File map table block, FMT block we have. So based on FMT block, we will again get the information of different various things from here. It can be in terms of hybrid, or it can be classical approach, or it can be two-level FMT. Any one it can have here. Okay. Now you see this one before and after they are trying to show here. This is before and this after. So before what is happening? Before closing the file, what all things are there? File system data structure. So how the data structure of this file system we have before the operation and after closing. Before and after closing. Before you see what is happening. So directly FTP pointer we have. It is pointing out for the information. What information we have? It is pointing to that information, and that is pointed by FCB pointer. Similarly, we have one more FCB pointer for the FCB file name. This is the file name. Okay, based on that, we can able to access the file and we can able to close it. Okay. Now what happened here? You see this one here. After close, before closing, these many things are there because we are pointing out the information. So based on the information what we point out, the file is getting access from FMT. This one, you see this one. FMT is what? File map table. Based on this file map table information. So based on this file map table information, the things are getting executed. The process is getting executed. So this is before closing. After closing, what will happen? After closing, what will happen? There will be no process. This complete OFT, will be eliminated here. You see before the E part here, there is no OFT here. That is eliminated. And what all changes they happened here? They updated the information of this. The file name called PHI is there. Right? This PHI is your file name. This file info, okay, is getting updated in this. So it's updated here. Okay, and then that corresponding FMT PHI table, it will be created and updated. If already created, it will update. If not created, it will be created. Okay, so any doubts in this? Very simple. Before closing the file, we have this corresponding OFT block which is active, and after closing the file, this block of OFT is being removed. Okay, so in this way we can able to analyze and update the information about the file closure. The file what we opened, we have seen, and file what is processing we have seen, and after closing what is that we have seen. And now there is something called file sharing. Okay, so this file sharing will have two methods. One is sequential sharing, the other one is concurrent sharing. What is sequential sharing? Only one process across a file at a time. Only one process at a time. Only one process a file at a time. Only one file at a time. We cannot take multiple files. One by one we should take. Sequentially, first file, second file, third file, fourth file, we are going to take. Okay. And implement through lock field in the file. Implement through lock field. What is this lock field? So, because lock field if you use only if file 1 we are trying to access, file 2, 3, 4 should not get opened. So only one we need to allow. Other fields should not, like how we have the access here, right? When we give admit only, we will be allowed inside the classroom. So similar to that, we have the lock field availability when it sequential manner. And what is the second one is concurrent manner. Concurrent manner is what we are trying to use to FCC. File control block we have. The file control block will be defined before itself, that whom to allow, whom not to allow, based on that the file, which one has to come, which one should not come, will be defined, right? So based on that we can take the action. Okay, so it will have a three sharing modes inside that. So three sharing modes are there inside that. That was there in that table. You can see that. And next is file sharing schematics. What are the file sharing schematics we have? So this is going to determine how the results of this file manipulation is performed by concurrent process are visible. How this concurrent process is going to do something. Okay, how that things are making visible is what we want to do in the file sharing schematics. So these are the three things here. That's what the table they told 13.4, right? So this is the table here. There are different modes we told, right? For that, mutate files, single image mutate files, multiple image mutate files. There are three things here. Mutate files, single image mutate files, and multiple image mutate files. Okay. The file being shared cannot be modified by any process. The file being shared cannot be modified by any process. Once you create a file, like we say, right, we have different mutations we call, right, immutatable. It means further it cannot able to mutate. That's called as immutable. Okay. So what is that immutable? Once you create that, that's all. You cannot able to do any changes. That is called as immutable file. The files what we share now, that's all. There are no changes can be possible in that. That's fine. That is called as immutable files. Next is single image mutatable files. Single image mutatable files is what? We can able to see all the process concurrently sharing a file, see the same image of the file. That is, they have an identical view of the file data. All of them can able to view it, okay, and thus modifications made by one process are immediately visible to other process using the file. So whatever modifications you are going to do, that will be visible using the file. That is called a single image mutatable file. Everyone can see that, and anyone change. Let us say now you see here, I am going to erase this one. So this is single image mutatable file. Further, if I do it, it will not come, right? So multiple image is what? Try to understand. This is clear for us. Don't need to worry too much about it, because it will not. Once you shared it, you cannot able to modify it by any process. Any process cannot able to modify it. That's clear. Now in this two, you check this two and this one and this one. You check. What's the difference? We read these two. So read this two. The process sharing a file may be different images. See this one, you can see here, same image. See this one, same image. The difference you try to understand is single and multiple image. Okay, this is mutatable file means what? Whatever changes you do, it will be visible. Here also, whatever changes you do, it will be visible. Okay. Single image and multiple image. The only difference is what? We have a same image of file we have, and we have different images of files we have. So the two differences what we have. Okay. So thus updates made by a process may not be visible to some concurrent process. Sometimes there are multiple files to create, but any changes you do there not be visible for all the process concurrently. So that's the small difference here. And the file system may maintain many images. See this point here, there are many images, but there are, in the above case, it is only single image, but now here it is many images of a file, and it may be reconcile them and in some similar manner to create a single image file. Later, it may try to create single image file whenever the file is getting closed. Okay, you see this point very important here. Create a single image when process close the file. After closing the file, whenever the process is going to close the file, all these multiple image mutatable files will become as a single image file. Whereas in this case, from the beginning, it is single image, and after closing also it is single image. Okay, is that clear? It's an interesting one. The modes of concurrent file sharing. So this is in case of single image mutatable file. There is only one image, right? Only one we have. Okay. So it gives the information to the data blocks and the empty table. Okay. And this also we have other information. Both of them are viewing this. You see this one? There is single process. Both of them can view it. Okay. Any changes he is going to do in alpha P1, alpha P2 can see. If he is changing from 1, 2, 3 is the number displayed here. 1, 2, 3 was there. If you want to change this 3 to 8, they made 3 to 8. You also can able to view that. Okay, this is concurrent sharing. This is happening in file sharing. Let us say you yourself and your friend want to share one file among yourself. Want to share the file. So you use the Google Sheet. You have shared the file. Whatever changes you are doing, you are changing into it. So you can see this here. That is your single image mutatable file. Whereas you have not shared the file, you have shared the folder. That is multiple image file. This is separate and this is separate. Both of them are doing it, so both of them can be viewed. There is separate entity for this and separate entity here. But whereas when you are trying to close the file, this will close like a single multiple image. Okay. Mutatable means what? Very simple. Whatever changes you are trying to do here will get reflected to other one. Okay. So what is the reliability in case of file systems? File systems. Okay. So what is the example here? Degree to which file system will function correctly even when fault occurs. You created one file, okay, everything is fine. Then you got a fault. Still, how can you rectify that fault and overcome that and open the file? For example, data corruption in disk blocks. In your hard disk, data got corrupted. What kind of mechanisms you can do to retrieve the data? Okay, let us say what will happen whenever your laptop or mobile phone, if you do not charge properly, it means you do not have good charging practices. Okay, so the battery what we are using in mobile phones is lithium ion battery. There is no, before the batteries are not of that technology. What is the best way to do is you charge it and discharge it. Let us say you have a battery cell like this. Okay, now inside this battery cell you have the charge. Complete charge was there here. Completely it is full. It is full charge. Okay, what you need to do is you need to wait for the battery to get drained off. What we need to do is again this same battery what you have, you need to wait to get it to drained off. That's the best practice actually in the traditional way they are trying to use. It's going to get drained off. This much charging only is left. Now you need to plug into the charge. That's the best practice. But nowadays this lithium ion battery, even the charge is up to here at this level, you can connect to the charger. Even the charge is up to half level, even this level you have, you can able to connect it. That's not a problem. That's a good practice only. It's not a bad practice. Okay. So what's the point I would like to say here is whenever you are trying to charge your mobile phone properly, the battery life will be good. And based on the battery backup life, the hard disk also functionality will change. Let us say you take your laptop. You have removed the battery and you have biased the power supply to the laptop. Will it work or it will not work? You have a laptop with you. Your laptop battery you have removed. And you are trying to connect the laptop with the power cable. How many of you will tell it will work? You have a laptop with you don't have a battery, laptop battery is not there, and you have connected the laptop charger directly to the laptop. Will the laptop be on? You can on it or no? Yes or no? Can you raise the hand? It will work, right? So when you work on like that and you are trying to get power interruptions, the data will get corrupted because the hard disk will get damaged. Okay. The two principal aspects are there. Ensuring correctness of a file creation, ensuring correctness of file creation, deletion, and updates. Ensuring correctness of file creation, deletion, and updation. File created, deleted, and updated. All these three things should be proper. Preventing loss of data in file. We need to prevent the loss of data. Two principles we need to do. First thing is file how to create, how to delete and update. First thing. Second thing is how to prevent the loss of data in files. These two things. And next thing is fault detection. The defect in some part of the system. The defect in some part of the system. Occurrence of fault causes a failure. Whenever you got a fault, that because of that fault you're going to get the failure. What does failure mean? It doesn't behave as per the routine. It behaves differently. Okay. So that is called as unexpected behavior is called as failure. Right? So these are the things what we need to know for the file system reliability. And this is not required. Lots of files recovery. These things are there. These are not required. So in the next class we will begin with module 5. Any doubts you have or any clarifications you have, please ask me. Right? So I'll just show you module 5 what we have. You have an idea or introduction about it. That's about your module 1. Sorry, module 4. So let us see now the updated in your file section. us see module 5, what we have here. Okay. For this module, we need to refer this textbook, chapter number 9. Okay. So this is the 2. So this is all the content what we have. Let's glance this content, look at them, and we'll discuss about this module 5. So this is completely this one is to go to this content. So this is your introduction to module 5. So these are the contents what you have in your module 5. How do we do the message passing? Right? How to implement this mailboxes? What is the deadlocks? How to handle the deadlocks? How do we prevent the deadlocks? All that. Control this. Okay, so is that clear? So next class onwards, we'll discuss the topics on the overview of message passing, implementation, and what is the concept of mailbox. And this is one of the important concepts, deadlocks, and how to allocate the resources for that, and how do we handle the resources, and how do the deadlocks can be handled, what algorithms we have to prevent, and all that we are going to see. Okay, so this is what we need to do for the uh, next class. Is that clear? So as of now, you have any other doubts or questions, please let me know. Is that clear to you all? Any other questions you have? Any other information related to anything, you can please ask me. Any one of you, module 4, any doubts you have, you can go through and you can ask me related to that. And I have told you multiple times related to your assignment. I'll just review that once. So I'll just confirm it, just a minute. So let me review this now. See this one, seems like many of them have not used 1. The default only it will be taken as 0 if you not attempted it. So these many people have not turned in, and still Sheikh Malik Baba even have not seen it. Gayatri has not seen, Chandan Mahesh has not seen, Supreme, Kiran, Janardhan, we are not viewed at all. These many people have not turned in, these many people have not viewed. It's okay. At any point of time, we can do it. But related to academics, we need to complete the assignments. So this assignment was given. The June 1st is the deadline for this. So not turned in, so it will be taken as 0. 8 is not 0. At least you have viewed it, right? I can consider something for assignment 1. You have viewed it, I am not seeing anything. If you have not viewed it, you are not interested in submitting. So you can return. Because we have viewed it, I am giving time for you for today to complete assignment 1. So these many people have viewed it. Okay, these 2 people I have to evaluate. The rest all people have returned, I have returned them, all of them. Some of them I wrote the comments, some of them I have written properly. So all of them they are given. Okay, the marks are one. Not pending anyone. So this one, who have viewed, I'll wait till today. So these many people, Vinayak, Madan, Harshavardhan, Kavyas, Darshan, Hruday, Akshita, Chandan Nayak, Janathan. I'm going to review it. Today you are going to submit it, I am going to evaluate it. If not, I have to return 0. I don't have any other option to do it, right? Because almost it's more than 1 month assignment 1. Similarly, assignment 2 also I am going to review it. Those who have not turned in, so they feel like they are not interested. Because it's been given long back to you. June 22nd is the last day. So if you want, you can return it today. Okay. If you want to still submit, you can submit it. I'll evaluate it. Okay, but to make you aware, I am returning it here. It is not the final marks. So clear? If you want to submit, you can return to that. So for those students who have viewed, I am giving time for them to complete it. Okay? So you can submit it as early as possible. Even I have given 0 for those students just to make them aware. They'll open and view it at least. What is the assignment? They'll see that. That's why I have returned it. There is no other reason. So at least to view that. Okay? Who have viewed it have not submitted. These many people have not submitted. Kindly make sure that you submit. I'm not asking for the module 3, 4 right now. I'm asking for assignment 1 and 2. Okay. So related to assignment 3, the due date is tomorrow. Only this many number of people have submitted. Only submitted is this many. It seems like they are the one who are submitting wrongly. The other students have not submitted at all, and let us see how many of them have not viewed, not turned in. Not turned in, but at least these people have viewed. They are in the process. So these many people have not turned in only. Chidambar, Mallika, Srinidhi. These many people have not turned in. Okay. I'm not telling this is the deadline for long back. Assignment 1 and 2 is confined for last month, June 1st. I have planned June 1st extended date. IA is over, second IA is also over, but the first IA assignment is not submitted yet. Yeah. Good, 80 people are returned, the remaining people will submit. Okay, yeah, that's it from my side. Any questions and queries? You're welcome. If not, you can make a move. So we'll start the module 5 discussion in the next class. Okay, thank you all. You can leave the meeting. If anyone have any doubts, you can stay back and discuss. Or else you can make a move. Thank you all. Anyone have any questions and queries, you can ask. If not, thank you. You can leave the meeting. Okay, thank you all.